Thanks for your patience, everyone. We will now get started. So we're going to talk about DevOps and how it's kind of a foreign language. And actually, specifically, we're not going to talk too much about DevOps. I'm going to talk mostly about linguistics. So just fair warning, if you're expecting to see lots of code samples and things like that, you're not going to. But we're going to do a little bit from linguistics, and we're going to talk a lot about the topic of just like how humans learn things, and maybe some of the reasons why learning DevOps is so hard, and so why it's not really a field that lends itself to juniors. So I like to start with this quote from Kelsey Hightower. For those who don't know who he is, he's one of the creators of Kubernetes. He said that learning Kubernetes doesn't take 3 days or 3 months, right? It takes 3 years. And he said this in 2017. Does anyone know what year Kubernetes was released by Google into the world? Exactly, 2014. So I'm really curious if we talk to him now, if he would update this answer. But basically what I'm trying to convey here, right, is like in the world of software development that we work in, we've got these black boxes that we sometimes have to like open up and examine what's inside them and know how they work. But as we've kind of built up these layers and layers of abstractions over the years, those black boxes have just gotten bigger and bigger, and there's more and more of them. So we've kind of just layered on a lot of complexity that makes this a little bit challenging. So quickly, a little bit of my background and just why I'm qualified to talk about this. I dropped out of college to do software development because it's way more lucrative than linguistics. But before that, I was studying linguistics. And I'm a developer advocate at Altinity. We do hosting and support for ClickHouse. That has nothing to do with this. I also like to talk about observability. Maybe we'll get to do that more on the unconference on Sunday, which should be awesome. All right, so what are we going to talk about? I'm going to talk about Linguistics 101. I'm just going to give like a 5-minute intro to just like what you would learn from a first year linguistics course in college. I'm going to really quickly introduce the topic of second language acquisition, which was the specific topic that I studied. It's all about how adults learn second languages, right? So children kind of have this innate ability to learn languages. Adults don't. And when I say second language, I really mean any language that wasn't one of your native languages that you grew up speaking, not necessarily your second language. We're going to talk about 5 hypotheses of like how adults can learn languages better. And then finally, we're going to bring all that back to like what we do with DevOps and how we can kind of apply some of these practices. Okay, sound good? Let's dive in. All right, so just to kind of illustrate how languages are a little more complex maybe than we give them credit, right? Like we kind of all think of languages as something that we're an expert in because we speak one fluently, right? So of course I know how a language works. But it's actually a little bit more complicated than we may understand. So this is a really common question that comes up, or sort of like a myth that comes up a lot in sort of the social zeitgeist, is how many words do Eskimos have for snow? Has anyone seen a specific number as the answer for this that they want to shout out? Sure, that's a perfectly valid answer. The New York Times science section, just one section of one newspaper over the span of 6 decades, reported this number as being anywhere from 4 to 212. So there's a lot of problems with this statement, right? First, what are Eskimo languages? There's actually not really anything that you can call an Eskimo language because there's like whole families of languages that have different relationships and, right? Is it a language? Is it a dialect? How do we discern these things? How do we discern the lines between words, right? Is snowing a different word than snow? Is snowbank a different word? So like this is a really, really fraught statement. But it just kind of illustrates the point that like, we all think we're experts in language. There's lots of these ideas about languages that proliferate and become widespread that are actually grounded in nothing. Okay, here's another example of how complex languages are and how we don't actually understand them as well as we think we do. This sentence is wrong, right? We all identified this sentence as wrong, and the asterisk at the end is a trick that linguists use to mark a sentence that is grammatically correct, right? If you looked up the words of this sentence in the dictionary, it works. It follows the rules of the English language. Kind of. There's like something that a native speaker in the middle would identify as completely wrong, that maybe a foreign language learner might not identify as wrong, right? It's the order of those adjectives. I actually read it backwards the first time. Yeah, it like breaks our brains to see it this way, right? Can anyone articulate the rule that is violated there? You're supposed to put more inherent adjectives for like first. That's what I thought the rule was too when I got this as a first year linguistics assignment. That was what I came up with, is that the more inherent adjectives go first. There's actually a very, very specific order, and it has like color, right? Like all these properties like color, size, quality, judgment, they all come in a very specific order. I think there's like 8 different classes of adjectives, and they have a very specific order that every single English language speaker, native English speaker, can do in any combination of adjectives. We can do it, but we can't. I even learned this order and I still can't articulate it, right? Because but I know it inherently. So languages are really complex and they have lots of rules that we maybe even speakers can't articulate, but we do know them inherently. Here's another example of how complex languages are. It's raining cats and dogs. Everyone knows what this idiom means, right? The meaning of this idiom has nothing to do with the form of the words that make it up. You can't really look this up in the dictionary, right? So, all right. I'm going to do what was said not to do earlier in this room, and I am going to read a little bit of this slide at you all. Don't read the whole thing. It's really, really long, but I think this part's really important. So I'm gonna put it up there and I'm gonna read it. It encodes cultural knowledge, values, and worldview, right? Language is a medium for expressing identity, fostering community, and transmitting ideas. That's the really important part, right? Another important part from this is that language is shaped by the people who use it. So it's not this static thing that just sort of exists in a perfect form and never changes. It's a constantly evolving and changing thing shaped by its use. Specifically, I'm speaking about spoken language here. Written language is a little bit different, but just for anyone who wants to Google this, we're talking about spoken language here. All right, so human brains are really, really good at learning languages as children. In fact, children don't need any explicit instruction in order to learn a language. They will learn languages simply from being exposed to them, which is pretty awesome and really an essential part of being a human, right? But we lose that at puberty. At puberty, we lose that ability to learn a language just by being exposed to it. And we need to have a little bit of formal instruction. We need to have a little bit of studying. And we're also never really going to be able to achieve that same level of fluency where we can identify all of those nuances of rules like the order of adjectives. But we can get pretty far. All right. So yeah, I already explained this, right? All children have the capacity for natural language and they'll learn one simply from exposure. Okay, a couple of disclaimers. Because we're going to talk about languages a lot, I just want to throw some disclaimers out there. Like the Eskimo example, right? Like generally, let's just not make claims about languages that we don't speak natively. And even the languages that we speak natively, we might not know as well as we thought we did, right? So let's just not do that. All natural languages are equally expressive. There's no natural language that's better for any one purpose than any other. And mocking or disparaging any natural languages is just unacceptable because that's probably the native language of someone, and really mocking their language is just a stand-in for mocking them. So we're not going to do that. Now, that being said, constructed languages like Java or Esperanto are not natural languages, and written languages are also not natural languages. What that means is we can feel free to make fun of Java or PHP or whatever our least favorite programming language is, and we're not hurting, well, we might be hurting somebody's feelings, but it's not an inherent quality about themselves that they can't change. So I'm going to say that's okay. All right, so what is second language acquisition? It's the study of the process by which adults learn new languages after they lose that innate language learning ability in puberty, right? And really, it combines lessons from a number of fields. So we've got a little bit of neurology and physiology, there's linguistics, and then there's sociology and psychology. Kind of take the intersection of all of these things, and it all contributes to this body of knowledge of like how adults learn. How is this relevant to us? Why are we talking about this at a tech conference, Josh? All right, so SDLC stands for Software Development Lifecycle, by the way. All right, can anyone tell me what command you use to see which version of Docker is installed on your machine? Any guesses? I heard -- version. Anyone have another guess? Yeah, just the subcommand version, maybe, right? Or sure, that might work too. That's another way. Okay. Now, here's what I actually did. So I did both. I'm going to talk about what results I got in a moment. But before I do, how did you all know that? Did you ever look it up explicitly for the Docker binary? No. You just kind of knew it inherently because it was like a cultural norm that had been established in other tools that you used, right? Whether it was -help or -version or subcommands, these are all just cultural norms that we're sort of familiar with innately. And maybe when we just tell someone to like read the manual, that information isn't necessarily there, or it's not there in a way that is understandable to them with their limited understanding of all of the black boxes that we understand. So I ran docker -- version just to kind of like test this out for myself. I was like, I'm not going to look it up. I'm going to figure it out the same way anyone in my audience would. Ran docker -- version. I got that result back. Nice. It worked. Okay, let's see if the subcommand works. And my terminal just hung. I got no results back. Nothing. And now so I dug into this a little bit more, and now I know why. It's because docker -- version gives you the version for the Docker CLI. And Docker subcommand version gives you the version for the Docker daemon, which when I ran this command, I didn't have running. So here's a bonus question for this. Does a bootcamp grad know how to control C or like escape a hung shell? Like if you just took 6 weeks of JavaScript, are you escaping this situation without closing your terminal? Probably not. So that's kind of a frustrating experience, right? And I also want to point out that like pretty much any DevOps tutorial that you do in 2025 is going to involve some Docker containers. And it might say something before even step 1 of the tutorial that's like, make sure you have this version of Docker installed. Holy cow, we are dropping people off of a cliff before they get to step 1 of any tutorial. So we're doing them a huge disservice as they're trying to learn. And this is like, I'm picking on Docker here, but this is true across so many of the tools that we use. So really what I'm talking about, right, is the implicit knowledge that we all kind of have, but don't understand that we have, and the explicit knowledge that we picked up from reading explicit sources or from reading the manual. And that's really what I want to get at in this talk is like, how can we kind of address some of that implicit knowledge and make it easier to grok? I think we kind of naturally understand this in other spheres of human life, right? Like we don't just tell someone how to ride a bike or have them like read a book about riding bikes and then expect that they know how to ride a bike. That would be kind of ridiculous, right? We give them help through the learning curve in the forms of like physical assists here, training wheels, right? I kind of think this is how we do it when it comes to DevOps. So there's a lot of confusion here, right? Like this is a brand new junior SRE with a shiny MacBook, and they might get somewhere. They will get somewhere, but there's got to be an easier way, right? Like, yeah. So here's my hypothesis. Successful software practitioners require an abundance of implicit cultural knowledge, which may not even be acknowledged by the people that they're trying to learn from. All right, so now let's talk about linguistics again. Stephen Krashen, he's still around, but he wrote this seminal paper in the field of second language acquisition back in 1982, Principles and Practice in Second Language Acquisition. In this paper, he outlined 5 hypotheses that are collectively grouped often under the input hypothesis, but I put that one second because I think they're easier to understand in this order. So we're going to go through each one of these in detail, so don't worry if these words don't mean a lot to you yet. Acquisition and learning hypothesis, the comprehensible input hypothesis, which is really the important one that ties this all together, the natural order hypothesis, the monitor hypothesis, and the effective filter hypothesis. All right, so let's go through each one of these, and then once we've done that, we'll talk about how it applies back to DevOps and what we can do about it. All right, the acquisition and learning hypothesis. Humans learn best by combining theoretical knowledge with real-world knowledge acquisition. So this is a tool from the world of physical education. It's used commonly in sports and martial arts and military training. It's called EDIP learning, and it has these 4 phases: explain, demonstrate, imitate, practice. I think this is a great sort of encapsulation of the acquisition learning pipeline, right? So you have the ideas explained to you, right? You have someone demonstrate to you how the ideas are applied. You apply those same forms that they showed you to solve the same problem, right? That's imitate. And then practice is taking those forms and applying them to your own, right? Recombining them in novel ways and solving your own problems using those forms that you previously imitated. And we can kind of do this as a loop, right? This is kind of like an iterative process that we're going through. We're doing a little bit of theoretical understanding, then we're applying that to practical experiences that sort of like cement it into reality for us and integrate it into our body, our mental models of how the world works, right? But then this doesn't just happen once when you're learning a new skill. You actually have to go back and forth through this process over and over again. I love to go back and read the docs when I'm like several months into a project and see how much I missed the first time around, right? And conversely, like if you're only ever reading docs and doing tutorials, you're only ever getting to that imitate stage. You're never like taking the forms and making them your own and making them tools that you can apply to solve unique challenges. So we have to go through this over and over and over again in order to build up our bodies of knowledge. While we're doing that, like how much do we learn with each iteration, right? So humans learn best when exposed to new inputs of size I+1, where I represents already familiar concepts. This is what brings this all together, right? So realistically, we want that I to be as large as possible relative to the 1, because that's what makes this easy for the brain. With as complex as DevOps has become, that's a really long journey, right? To get that I larger. All right, so here's a demonstration of this and how it works in our brains. Can anybody, now actually, if you speak Spanish, even a little, don't answer, please, no cheating. If you don't speak Spanish, like me, can you tell me what caballete means? The second line on the second word. Second word on the second line. Maybe. Yeah, so I got some guesses. I didn't hear a right one. Now, can anyone tell me? Yes. So that's, to me, the perfect encapsulation of I plus 1, right? Our brains are capable of filling in some gaps and sort of extrapolating from patterns that we recognize, but only if we can recognize, right, the pattern surrounding the missing piece. If all we're given is missing pieces, things that are completely incomprehensible to us, we're not going to be able to get to learning a new word. Okay, the natural order hypothesis. So there's a natural progression for learning complex systems like languages. This actually plays out when infants are learning languages, right? We actually can see biologically that there's like, languages kind of have like a DNA that can almost be expressed in binary. It's just like, does it do this, does it do this, does it do this, right? And babies tend to kind of like learn those features of the languages in the same order as they're learning the language. It's really, really cool. Definitely encourage anyone who's interested in this topic to study more the process of how children learn languages. But that's not what we're talking about today. We're talking about adults, right? Oh, I missed a slide. Oh no, that breaks my whole point. Well, imagine that before we saw this, we saw a tech tree for a video game that was, what? Yeah, that's the next one. So there was a worse tech tree that was very, very complicated. I don't know how that slide got deleted. Anyways, it's a very, very complicated tech tree, and it reminds me of this. So this image, first of all, it's a testament to the success of the CNCF and the Linux Foundation. All of these projects are awesome. I love many of them. I've worked for some of them. But for someone who is new to the industry, this is a completely overwhelming landscape. And it doesn't really give you like a you are here or start here or any kind of path through it. So that's a little challenging, right? That this is kind of the box of things that we call DevOps has gotten really, really big. So this is another tech tree from another video game called Civ 5. I like this one a lot because unlike the one that you didn't get to see, it has a progression. It has a natural progression, right? Everybody starts with agriculture because you can't have any other technology without that. If we take this back to like our world, right? Maybe this is Git or like CLI, just like basic CLI bash, right? Like you need that because that's how you're going to interact with all of the other tools. And then after that, there aren't 20 choices or 200 choices. There are 4 choices. So like maybe in our world, you're going to go into networking, or maybe you're going to be like, you know what, virtualization is really my thing. I want to learn that deeply, or I want to learn a specific programming language really deeply and understand how the runtime for it works and the compiler and all of that, right? So you kind of have these paths, and eventually you will get to that full complexity reflected in the whole CNCF landscape, right? You'll eventually get there, but you're going to have a guided path that gets you there incrementally, that works with that I+1 learning, right? All right, then we have the monitor hypothesis. So basically, we all have an internal monitor, right? Like that slide where I had the asterisks with the adjectives out of order. We all kind of had this internal buzzer in our head going like, that's wrong, that's wrong, that's wrong. And we have the same thing when we're about to utter something, we're about to say something, and we know that it's wrong. There's like a monitor in our head that's like, that's wrong, and then we don't say it. Or in the case of natural languages, right? If we're learning a foreign language, maybe we'll know it's wrong, but we'll try it anyways because we need to communicate. We need to buy lunch or find the bathroom or find the train station or whatever it is, right? So we need to communicate. And so that need lets us break through the knowledge that what we're saying isn't maybe perfectly correct, but hopefully the person that we're speaking to will understand us. So this can actually be really challenging when you're learning a foreign language and like people won't correct you, right? Because you need feedback in order to train your monitor and make it better. But you will break through it, you'll try. You won't necessarily get feedback. On the other hand, with programming languages, you're going to get instant feedback that is very, very harsh, right? If you have one single character wrong or one single capitalization wrong or a space where it shouldn't be, you're going to get something completely incomprehensible, most likely. So it's very, very unforgiving of small mistakes, which can lead to people not being willing to just like try it, right? I'm afraid to type docker -- version to see if that works because I don't know that's going to do to the state of my machine and my ability to finish this tutorial, right? So there's a lot of fear that we have to overcome. So we need feedback loops. We need them to be not too strict, but not too permissive. Don't be afraid to admit when you don't know the answer, and also don't be afraid to try something. So it's a balancing act. One of the tools that I used when I was just learning tech and like learning how to build websites was Dreamweaver. Maybe you used FrontPage or something similar. What it had was an instant feedback loop that was also very permissive because like HTML browsers will just make their best effort to render it, right? Even if it's incorrect. So unlike other programming languages that just won't compile and you'll get some weird error that traces down to a library that you didn't even know you were using, HTML is very forgiving, and Dreamweaver and FrontPage and these other tools gave you an instant feedback loop where you could visually see the instant results of whatever you were typing. So that's an awesome way to learn. I also think that's one of the reasons why like WordPress has sort of been this like path into tech for so many people, because it gives you this gradual learning curve from like, oh, I can just edit my CSS and write a few lines of CSS, all the way to like writing complete WordPress PHP plugins and themes. And it gives you gradual paths through all of that. Even if some of them are things that make us shudder as real programmers, right? Like, oh my God, you have a file editor like built into your admin. So yeah, things that maybe work for seniors, maybe make it harder for the people who are trying to learn. All right, the effective filter hypothesis. This is the most important one. This is really, really crucial. Motivation and mood are your strongest filters on your ability to learn. You're not going to have the same ability to learn every single day. And if you don't have motivation to learn a topic, it's going to be almost impossible. So it's really important to know why you're trying to learn a certain skill and to keep that in the forefront of your mind. I think it's also important to give yourself some kind of practical goal, right? Something that you can build for yourself that actually gives you some benefit. For me, a lot of it comes down to like experimenting with tools to like manage my schedule or find interesting conferences to submit talks to, or right, analyze code bases, right? So it's just whatever tools you can work on for yourself. And that's an important part because, right, when it's something for yourself, you have a little bit of a safety net. You're not like working on a production system, so you can break through that fear a little bit of like, oh, well, what if I make a mistake? So it gives you motivation and it gives you a safety net. And both of those things are really, really important. And I think it's also important that we acknowledge the humanity of our coworkers, right? Humans are humans. They're not always going to be at their best. We're building socio-technical systems. That's something that's just important to keep in mind. And we should make sure that we are providing a safe environment for our coworkers. Psychological safety is really paramount, right? This is really pervasive, I think, in SRE space of being blame aware, because you don't want people to hide their mistakes because that hinders your ability to make the system more robust and resilient. So psychological safety, good for the system and also good for the learners. All right, so what can we do about this? If I'm someone trying to learn the field, which maybe not so many people here, but maybe you have people in your life who might meet this, right? What can you do with it? Well, start with the basics. Start simple, small, and then iterate, right? Nowadays with vibe coding, I don't even know what a small example is, but right, for most of us in this room, it was probably, like based on the reaction I got earlier, HTML and CSS or like a little bit of JavaScript, right? So like start with something small and tangible, not like a whole AI pipeline with a RAG and everything, and then iterate, right? Each iteration, you're going to be fleshing out those mental models. Your eye is going to get bigger. It's going to be easier to integrate the +1. All right, embrace practical experiences. I already talked about this a little bit, right? Choose real goals that allow you to apply your theoretical learnings. So build real things. Contributing to open source is a great way to do that and to gain experience. Seek feedback. This is another one where the open source community can be great, because if you're just learning on your own, you don't have anyone to give you feedback. But if you go find an open source project to contribute to, you're going to get a review on your PR. Maybe you'll learn something from that. Maybe your monitors will get trained, right? So open source is a great way to get feedback, although you can also do this at your job. And don't be afraid to admit what you don't know. This industry is just massive. And I'm sure that anyone in this room could list a bunch of acronyms that everyone else in this room would not know. All right, and finally, stay positive. You've got this, right? Motivation and mood. And if you're having a rough day, like, it's okay. Take a break, walk away, come back to it when you're in the better mood to learn, and it'll be a lot easier. All right, so what can we do about this as the people building tools and platforms that other people are going to have to work with, right? First one, and credit to Adriana Viella, who gave me this item, embrace your early adopters. Your early adopters are people who have some kind of innate motivation, intrinsic motivation, that let them get through that pain on their own, right? So that's awesome, but not everybody is like that. But if you can find those people who did have that and talk to them about what was painful in their experience, then you can smooth those road bumps for the people who don't have as much intrinsic motivation, who might come behind. So early adopters are your best friends. Adopt them, embrace them, learn from them. Design for accessibility. Don't have a CLI tool that just hangs and doesn't provide an error message. Don't design your CLI tool so that the subcommand version and the flag -- version do completely different things that you couldn't explain to someone who's new and doesn't know the difference between a daemon and a CLI, right? So like, just, we can do so much better here. There are a few programming languages and tools that I think do a really good job here, but they're definitely in the minority. All right. And then we have to meet our users where they are, right? So this kind of gets back to what I was saying earlier about like the tools that work for us as seniors might not necessarily work for juniors. I really like strict types and strict type checkers and, right, like strict linters and validators, because I know the benefit that that's going to give for me. And it's also not going to slow me down that much, right? Because if it gives me an error message, I'm going to be able to really quickly resolve it and just move on with my build. But those things are just a huge amount of friction, right, for someone who's new and learning. And this is, again, why like WordPress and PHP, as very sort of permissive, open, dynamic languages, tend to be where people come into the industry from. So let users make mistakes, just like in my Dreamweaver example with HTML, or like, let users make mistakes, let them make forward progress if they can, if the mistake that they made isn't gonna just like gum up the whole thing. And also offer a paved path, right? This also comes from SRE. Give them a paved path, give them a path that's like, hey, if you do this and then this and then this, it's probably gonna work. You can give them options, but like, let's give people a single path through your tool. Let's not say, oh, well, you could install it with Helm or Terraform or like, here's my docs, and the getting started page has 17 different tabs. Let's not do that. Maybe three is good. So what it really comes down to, and this is near the end, so we're gonna have some time for some questions and discussion, which is my favorite part of this talk. Platform engineering is about reducing the depth of the stack for developers. And that's really what I've been talking about today, is platform engineering, right? Like, let's make this stuff easier for the people who are building on top of it. It's within our power to do that. This is a quote from Hazel Weekly. She's awesome, by the way. Look her up if you don't know her. All right, we already had this figured out once before, right? I mentioned Dreamweaver. It was really my first platform, right? It had everything I needed from a platform, actually. It had CI/CD. It had observability. I was golden, right? So let's make this fun again, right? I'm not saying we have to go back to like hit counters and GeoCities and AngelFire, but let's make this so easy that every 12-year-old on the planet can teach themselves. All right, so now I've got time for questions and answers and discussion, and that's a QR code where you can find my website. I will upload the slides later tonight. Those are all the places where you can follow me. And yeah, any questions? Yeah.
Two things. Adjectives in English absolutely have to be in this order: opinion, size, age, shape, color, origin, material, purpose, noun.
Okay.
So you can have a lovely little rectangular green French silver whittling knife, but if you mess with that word order in the slightest, you'll sound like a maniac.
Amazing. Thank you for looking that up.
Tone is really difficult to be able to control in what you're saying if something is presented in email or over instant message, Teams, something like that.
Yeah.
What are your thoughts on being able to not say something incredibly flowery and say, I don't mean it. This is what I'm trying to say, but still convey information in a straightforward way that does not seem hostile. Email always seems to have a hostile default flavor in everything that gets emailed.
Ooh, yeah, that's a tricky one. And it's also like, right, if you work at a global company, that can be an issue cross-culturally as well. I work with a lot of people from countries that tend to be very, very direct. So you kind of just adapt to that. But yeah, no, like written language is definitely fraught. I don't know that I have a perfect answer for that, but I think it's called, right? Like it's about the people that you're working with. So like, what is the culture? What is the relationship between them? And then, you end up in some like completely anonymous space, like a GitHub issues page on an open source project. And you just have to like really be careful. And I think also just maybe give each other some grace. Like, let's assume the best in whatever we're reading. And if we're assuming the best, maybe we're having one of those bad days where we just need to walk away and come back to it with fresh eyes. Yeah.
I ran a community for Puppet for many, many years, and I had a guide on how to engage with our community for our internal people.
Okay.
And it very literally had the sentence in there that says, "Did not mean they're just German."
Okay, so for those who didn't hear that through the microphone on the recording, it was the Puppet guidelines for engaging with community, and it was, what was it?
They're not mean, they're just German.
Oh, they're not mean, they're just German. Okay, yeah. So yes.
Being flowery and everything's up and being nice to other people, you get the job done, but tell you what needs to be fixed. Right? And so that's the way that they talk.
Yeah.
They're doing it because they like you. Same.
They're doing it because they like you. Yeah.
My second language, Hungarians are just as direct as German, and my communication was labeled passive aggressive. I'm the negative person. Like you've been working with open source communities for global, like give me some slack.
Yeah. I'm just Hungarian.
Like a little, I don't know, something on your forehead to remind people that I'm not from the same culture as you are, and that applies to everybody. Like US people are way too cheerful for my experience.
Well, of course. Yes. Yes. She's not mean. She's just Hungarian. I'm definitely adopting that at my company too. Bringing that back to anyone who wants to adopt that. More questions? Yeah.
More just like a discussion thing. I understand. So the example of like making a video game or something.
Yeah.
Just like doing something that learning through doing something you concretely want.
Yes.
Makes sense. I'm wondering what your thoughts are on like, because DevOps in particular is sort of a meta problem, right? That's like, how do we program about programming to make it easier to get our programs in other programs?
Mm-hmm. I like that way of putting it.
Yeah.
DevOps is meta programming. Yeah.
No, yeah. But so from a beginner's perspective, I'm curious what your thoughts are on like how you even begin to understand. Like if you're just making a video game on your computer, even if you have like a little TCP server that does some sort of multiplayer situation, right? You're probably not going to ever run into the problems that make someone want to reach for Kubernetes.
Sure.
So like, I guess how would you recommend people like, how do you find the good problems?
Maybe you don't need to learn Kubernetes first, right? So yeah, and actually this just reminds me of a fascinating story. So I was talking to someone who's been a game designer for like over 12 years. And I had to explain to him how an HTTP call works because it had just never been relevant to him. And that kind of blew my mind. An HTTP call works. So it's possible to go really, really far in some of these fields and just never touch things that we might consider immediately adjacent. But yeah, specifically on the example of Kubernetes, right? So like I have some friends who have development background and are now trying to learn things like Kubernetes and other DevOps tools. And it's the same principles that we were talking about for the other tools, right? It's like starting small and simple and iterating. So like, don't start with like, oh, okay, I'm going to do Kubernetes with Terraform and Argo and use the kubefirst stack and like do all of these things correctly, because that's going to be completely overwhelming. Terraform in particular, like, beginners should just stay away from it because it does too much for them and it abstracts too much for them. And if you don't understand what Terraform is doing for you, it can be really, really dangerous. But it's really, really tempting because it's like in the zeitgeist and people are like, oh, Terraform, Kubernetes, I need to learn these things. Oh, what's the easiest way to get a Kubernetes? Well, EKS color kind of stinks, so I'm going to use Terraform. Right, so we kind of have all of these paths that like lead people right into traps, and I guess that's kind of the point that I'm trying to make here is like, let's lead people away from the traps and maybe tell them that they don't need Kubernetes yet.
It sounds like you're leaning towards the question, what's a good first issue, in this case for Kubernetes?
What's a good first issue for Kubernetes? That's the question? Yeah. Oh, that's a great question. I don't know that I know Kubernetes well enough to answer that. The docs. Yes, actually, the docs is always a good first issue. Thank you, Chris. Yeah, and that is that's a very valuable contribution. No one else wants to do that. Yeah.
Did you spend any time trying to develop a Kubernetes ecosystem type tree for your?
I have had talks about it, like in rooms like this where I've given this talk, and then afterwards, like in the hallway, talking about it. So it's definitely kind of at the forefront of my mind. And I think the form that it might actually take is like, you know, all those GitHub repos where it's just like, here's all of these things that you can learn, all of these resources to learn on a topic. I want one of those that puts everything as a dependency of something else. So it's like, this is exactly how much you need to understand Docker before you learn any Kubernetes. And it's not all of Docker, but like go this far and then go learn Kubernetes. And then if you want to keep going down that Docker path, here's somewhere you can go. But like you need this much to unlock Kubernetes. Something like that. Yeah.
Is that the correct blue sky handle, or is there an extra E in there on accident?
There is an extra E on there on accident. Thank you. That's the one. Now someone sniped my blue sky handle. More questions? All right. Cool. Thanks for coming to the end user group track.